Hello, welcome back. So let me see who's in here. We have Aaron, Manny, Muhammad, Van, Rawa. Yes. Anybody else? Christian, Abdullah Gandhi, Monica, and William. Okay, great. Thank you. Yes, man, I get you. Thank you. William, JC, and Monica, are you here? Are you here? No? Okay, well, let's get started. So today, what we're going to do is we'll start with the discussion about the VGAs first. As far as I know, some of you, based on your response, you don't have access to VGA. Somebody you have access to VGA. Now, for this class, I I want to make it easier for everyone. Okay? If you don't have VGA for this class, that's okay. I'll let it go. I have a solution for you because for this class, I created a solution. All right. So what I want you to do is please go to ULearn and look at anything associated with D4. So please look at D4. So go to ULearn now. All right. Okay. So on D4, there are a few things you need to download. The first thing is the assignment itself. So I update the assignments, so we can go over it in a moment. And second, it's a VGA emulator I built for this class. So please download that one and download the sample BNP file onto your desktop and sample text file on the desktop. Okay, please do that now and let me know when you're ready so I can walk you through the process to use the email. Yes, make it easy. Put it on desktop. Let me know when you finish downloading these files. No, you need to download the files. So D4 files associated with D4. Are we done downloading the files? Okay, it doesn't matter. You can do this after. You can do this after. Just to show you how to use the emulator. Okay, it's not difficult. Plus, you can view the video. Alright, so by now, I assume everybody has finished downloading the files. Okay, so when you click on the VGA, it is a folder because the file is a zip folder. So what you need to do is you need to unpack it to your desktop. So you can just click and drag it to your desktop. You can see that it is unpacking. Okay, so after unpacking, you can close this and go to your desktop. And there is your folder. Alright, so if you look at this folder, it's called Application Windows 64. That means this particular application only runs on Windows 64 bits. If you have a machine that's not 64 bits, this will not run. Okay? And oh, it doesn't have to be VMware. You put it in your Windows. This is not VMware stuff. Okay, so let's change the name. Let's call this VGA underscore CO3 because this is the third revision I created for this class. Uh, there was first revision, second revision. This is the third revision. There could be a fourth revision in the future. I don't know, but this is the third revision. All right. So if you rename this, this is what you have. So let's look at the file from class. Okay. So if you look at the URL, I give you the demo BMP. Okay. See that demo BMP. So I also download that to my desktop. If you double click it, this is the file contains the image that you need to process. Okay. So this is the original BMP file that you're supposed to put on your SD card and then process it. Alright, so this is the file. So pay attention to the detail. This is how it looks. Okay, nice in-game wallpaper. Okay, that's good. What if I know Christian? Christian is here. No, okay. He's not running in VMware. Just put it on Windows 10. And this file is the file generated by the program, Arduino program, and extract the pixels and convert it into the format for the emulator. This is not the format that I used for the emulator. So usually our plans to use everything for the VGA. Since not everyone has VGA access, so I cannot force you to the VGA. So instead, we're going to use the emulator for the assignments. So now we're going through the operation for the emulator. So this file contains everything in this file. So the BMP has been extracted, processed, and dumped to a TXT file. Alright. So now I will show you how to use the emulator. So let's go to the VgaEmulator, and there's executable. You can see that it says application. You double click the application. As you hey, you want to run this software, it's not signed. Of course, I created this distributed publisher. And if you have antivirus to tell you this could be a virus, you say ignore it, just run it. Okay? You run, it asks you, hey, select a file. And then it's looking for TXT files specifically. So looking at this, I have demo3. Okay? So demo3, I'm going to say open, and then to wait for there a little bit. And then here is the image. Okay? Let me see what's the big deal. Well, the big deal is now, if you want to test your program, generated by the Arduino, which process the image data, you don't have to use a VGA anymore. You can just test your file using this. This is going to be your demonstration. You don't have to use a VGA. You can just use the output. Okay. I know you know those guys. I know those guys too. Okay. All right. So once you do this, this shows that the file that you generate, for example, in this case, I used the D3 demo. It has all the pixels data for each pixel. And you can see that the clarity is not as good as the original picture. The reason is the original picture was 24 bits, and this picture that you generate using the Arduino program is 8 bits, so you lost some clarity. That's why you can see the picture doesn't look that sharp. Okay. All right. So what I want you to do is I want you to do is to run the D4 sample.txt, which is I gave you on ULR, and tell me if you can see the image. I'm not going to tell you what image it is, but run it. Tell me what image it is. Okay. Please do that now together. If you finish running the program with the sample, D4 sample, let me know the content in the file. You can type it here in the chat. Exactly. So if you do it properly, select D4 sample. This is what you should see. Okay. You can see that I did not draw the angry bird, but I did enhance the picture with some engineering touch. Remember, if you do not select the BMP file, you select the TXT. This emulator is not to process the BMP file. This emulator is to process the text file. Okay? Yes, I know it works because I will test it thoroughly. The VGA35 is on ULearn. You missed the beginning of the class. Go to ULearn and download the package. Okay? Okay, so far I have two students confirmed. Aaron, Rama, confirmed. Anybody else? What about the rest of the class? Can you confirm you have it working? Sorry. Can you confirm you can operate the emulator? Okay, good. Christian's good. What about Ben? What about Muhammad Akaudi? Muhammad Akaudi. What about Abdullah Agamdi? Are you good? Is Monica here? JC? Or Jesse is here? Monica? Jesse? No? What about Ben? Are you good? Okay, Ben, what's wrong? So Ben, what's wrong? Why is it not working? You just need to unpack the files, put it at desktop, and just execute the program. Yeah, you got double click, run, sample. Okay. Yeah, you have to put everything, not just this file, but there are two more folders in the download. You need to do that as well. Okay, are we good? No, you have to select the TXT file, not BMP. This is the file. Yeah. The emulator doesn't process BMP. The emulator only processes the TXT. this is not an image viewer. This is a VgaEmulator. Are we good? Yes, default sample.txt was wrong. Okay, great. Alright, so let's close this. So starting day 4, you can demonstrate using the emulator. Okay, you don't need to use the VGA. Everybody have access to this. Alright, so let's close this. Let's look at what's inside this sample. Okay, so this is the original picture. This is the sample.txt. So you double click it, you can see that it has nothing but numbers. Okay. Um, one thing you should do is you should use a Notepad++ to look what's. You can see this is a better view. You can see this file has one number per line. One number. The number must be decimal, no hexadecimal, because the emulator does not read hexadecimal value. It only reads decimal value. And each line is terminated by comma. Okay, so number terminated by number. Okay. And if you keep scrolling down, the last line is 76,800. Okay. So now what we need to look at is what the emulator is expecting. Okay. So the first thing is the emulator expect a TXT file. Okay. It does not expect the BMP file. It expects a TXT file. And in the TXT file, each number in the file represent the value of a pixel, 8-bit pixel. Okay, 8-bit. Each pixel is from 0 to 255, 8-bit number. Right? Because the screen of the VGA is only 320 by 240. It means you have a total of 76,800 pixels. It means 76,800 numbers or 76,800 lines or 76,800 comma. Okay? That's why this file has 76,800 lines. Each line is a number. And if you scroll through this, not everything is 255. There are some other values as well. Okay? You can see that there's a chunk of zeros. Okay, 73. All right. And remember, because the limitations of the VGA emulator, the VGA emulator is trying to emulate the behavior of a VGA for the D8 line. Okay? It is not built to emulate a graphic card. So you have to provide exactly 76,800 lines. You cannot have one more, you cannot have one less. And also, each line must be terminated by a comma. If the line is not terminated by a comma, the VGA will not work. It will not give you anything meaningful. Understand? Alright. So this is good. Now, so far, any questions about what the emulator expect? The input expectation for the emulator. Anybody else? Safety here? Is the monitor here? If it is smaller than 76,800, it will not display anything. It has to be exact. It's looking for the exact number of lines because the VGA has only 76,800 pixels, so it has to match one to one. You cannot say, "Oh, I'm missing one. I'm going to do something for you." No, it has to be exact. Okay? Each pixel, it's 8-bit, is only one value. So the value of the pixel value, so the value of the pixel can be 0 to 255. Anything above that does not work. Okay? If you give 256, it means 0. If you give 257, it means 1. Okay? Because everything is limited to 255 being the maximum. It's 8-bit only. It doesn't handle more than 8 bits. Okay? So going back to the assignment, D4. Originally, the assignment was for you to create a text file which will contain the variable declaration for a two-dimensional array. Initialized it where the pixel value. Right now, we don't have a VGA, but it needs to. So we have a VGA emulator. So we still need to output to a TXT file. For example, look at here, TXT, D4 demo TXT. But right now, we cannot use the C syntax anymore. Instead, you have to use this format. One value per line. Each line is terminated by a comma. Okay? All right, can you hear me better now? Each line is terminated by comma. one value per line. Is the audio better? Okay, I assume yes. And continue. So, now we need to do is comma terminated decimal values. One value per line, linear configuration. So let's look at linear configuration. Now, if you look at this file, there are many values, but what do they represent? So looking at the first 10 values, okay? Yes, the size, not the image. Okay? We'll clarify that in a moment. So for example, this is what you get from the file. These are the first 10 values. So what do they mean? This means VGA location 0, 0. Okay? This means VGA, VGA location. What is this? 0, 1. Okay? 1. So this is row equal to 0, column equal to 0. This is row equal to 0, column equal to 1. Okay? Alright? VGA location row equal to 0, column equal to 2. Understand? So this will be VGA location row equal to 0, column equal to 9. Alright? And this is 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7, 8. This is number 8. Okay? That is 3, 4, 5, 6, 7, 8. Okay? So that means this particular format, you only specify the order of the appearance. You don't need to provide a location because we assume these locations, right? So when you output the file, you must provide exactly 76,800. Now, what if the image that you're getting is not 320 by 240? Okay? You have to make sure that the file you generate is always 76,800 values. If you do not have enough values because your input is small, you need to fill the unused lines with zeros, comma. Okay? So let me draw a picture. Suppose the image you want to do is this. Okay? It's a 4 by 4 image. Let's make it easy, 4 by 4. Okay, so you want to show this in VgaEmulator. You process your program, but you need to do this. So you're not using the remaining columns, right? So you need to fill them with all zeros. So you look at this. This one should have 320 values. Okay. 4 of these and 316 zeros. Same thing here. But this one will be 320 zeros. And same thing here. 320 zeros. And when the emulator reads in this, it knows that, okay, I'm seeing 4 different values, 4 lines, then I'm going to show you these 4 on the screen. And then it reads a bunch of zeros. You know that, okay, the remaining pixels will be all zeros, which is black. And it will continue reading your files. Remember, everything has to be 1 value per line. If you look at these files, the text file, it looks like this. Value, comma, value, comma, value, comma, and then 0, comma, 0, comma, 0, comma, and a bunch of them. Okay, and then will be like that. Okay, so it doesn't matter what the size of the file you're getting. You always have to make sure that the file you generate has 7,000, 76,800 values. Okay? If you don't do that, it will not show you anything. It has to be exact. Okay, are we clear? No, you do not do it manually. Please don't do that. You do it in your code because when you read in an image, you know that the horizontal and the vertical pixel size. We did that in D1. If you figure out that is not equal to 320 by 240, then you know how many zeros you need to fill. So your program is smart enough to look at, all right, I'm reading in 300 by 200. Okay, so that means every time I output 300, I need to output 20 values, that's zeros. Then I can output another 200. So 300, then another 20 zeros. So your program is smart enough to do that. But the maximum size is 320 by 240. The minimum size is 1 by 1. Okay, we cannot do anything, there's no limit. So the lowest limit is 1 by 1. The maximum limit is 320 by 240. But it doesn't matter what you do, you have to make sure that the output is always 76,800 lines terminated by a comma. And then the tool, this emulator will tell you, hey, line number does not match this value. So now we have the emulator. Everybody can perform D4. You don't need to have access to VGA. Write a new C program. It's not necessary. Okay? You can just use the emulator to test your results. The only help what you do is instead of using C syntax, right now you need to use this special syntax. Okay, for the emulator for the emulator. Because the emulator has to expect certain format. And the easiest way to do this is to do one value per line. That's it. Right. Any question about the emulator? So the D4 sample is for you to debug your own code. If your code doesn't come out right, you can compare that with your D4 sample and then figure out your bug. Okay? Yeah, I still do Thursday. Yeah. there's no there's no significant. In fact, it is less work because you don't need to write two programs now. You only need to do one program, which is your Arduino program. It's the newest program. You don't need to do that anymore. Okay. All right. So since no one has any question about this emulator, I assume everything is fine. Okay. All right. The emulator only works on Windows. If you have a Mac or Linux machine, it does not work. Understand? Yes, the original Arduino program that you you're developing because you have not finished development yet. You haven't submitted anything. The output is a C syntax, which is more complicated because you need to do it in a two-dimensional way. But this program, it doesn't use any C syntax. You just say, well, I don't care about your syntax. What I care is you give me one value per line terminated by a comma. That's it. Okay? And then also, you don't need to write the newest program. So that means 50% of the work is done. Right now, you should do the other 50%. Okay? So let's look at description. Instead of doing Arduino and News tool, right now, there's only one program you need to write. So here, the same. The only difference is this section. You need to output one value per line. Each line is terminated by a comma. Okay, and that's it. All right, so reminder, your minimum resolution is 1 by 1, your maximum resolution is 320 by 240. Remember, the physical Neos 2 VGA, the DE10 Lite VGA, this is the resolution that you can program. So the emulator expect this is the resolution. The resolution is fixed. You cannot change the resolution. Okay? All right. So there's only one source code you need to submit, which is the Arduino program. I'll give you my this Thursday during class a D4 demo. So when you do that, you run through your program, you get a D4 demo.txt from your Arduino program, and then you load that program into the VGA emulator. Then you can record the whole process, and then your VGA emulator will show you what the picture is. If you did everything correctly, you will see a meaningful picture. Okay, not some garbage. Okay, the image I give you always a good quality picture. Okay, so I recommend you is to look at the D4 sample.bmp and D4 sample.txt. So these are good tests for your program. The original image was this, and this image, which you use the emulator, you can see that they look the same. Okay, so this is your original image given to you after you are doing the processing. Okay, you get this. Understand? So now we don't need to use the DHL link because some of you don't have access to the VGA. There's nothing I can do about it. Alright. Any question about this? So starting D4 and beyond, anything to do with VGA, we're going to use the VEmulator. Okay? Yes? Question so far? Okay. Um, Reminder D6, which is a research paper, is due very soon. So please work on it. Okay? The next topic for today is the D7, which is another assignment that's nothing to do with code. If you go to ULearn, scroll down, there's a D7. Here is the D7 handout, D7 schematic, and then and a picture of the physical connector. So what you need to do for D7, the due date for D7, if you look at it, the due date for D6, I'm sorry, D6 is Thursday 30th, April 30th, before class starts. Uh, so for D7, it's about PCB design. Well, I haven't posted D5 yet. You haven't even finished D4. I'll post D5 once you finish D4. Okay? Alright. So for D7, you need to create a printed circuit board design, a PCB design using the Eagle software. Again, the Eagle software is free to use. I give you the textbook, ISBN number. It's a tutorial-based, self-paced textbook. You go through the chapters, you learn the tool. Okay? So for D5, the first thing you should do is create a schematic of a circuit. Okay? Before you make a printed circuit board, you need to create a schematic. Okay? All right. So this is the circuit you need to build. This circuit is from ENGN3055. Many of you are taking that class or have already taken that class. So this circuit is not too difficult to interpret. Your job is not to understand what the circuit will do. Your job is to understand how to make a printed circuit board. Understand? Okay. So if you look at this circuit board, circuit, you have resistors, each labeled properly, a very unique label. You have capacitors, values, and labels. You have op amps, 741, two of them, one and two. Okay. So if you look at this circuit, where is the input? Ready? Where's the input? That's right. This is your input. And where's the output? Right here. Okay. So the input is here to the resistor RST11. Output is here, is pin 6 of the op amp. Okay? So the circuit has input, has output, it has a ground, ground. These are the ground connections. Okay? It also has two power, VCC and VEE. Okay? So power, two of them. Ground is one, input is one, output is one. That means there are 5 connections to the circuits. Inside the circuits, there are many connections, but those are internal. Okay? So if you recall, when you're working in the lab, how do you make connections to the power? How do you make connection to the power? Okay? When you're working on a circuit in the lab, you use the power supply on the bench. Okay? And on those power supply, they have these kind of connectors. See this? These are the connectors that you use to connect to the power supply. And what do we call these connectors? We call these banana jack. Okay? Banana jack. Okay? These are banana jacks. They both exist on your breadboard. They also exist on the power supply in the lab. Okay? So when you make a connection, you can use a banana jack to banana jack cable or banana jack to clip cable. Either way is fine. Okay? So for circuit board design, we'll always need to include the connector to power, to input, and to ground. 5 of them for these circuits. Okay? That's why I find a picture with 5 different colors. Okay? In reality, people don't really need to use 5 different colors. But if they can get, usually we'll use different color for example, red for power plus, VCC, black for inputs, sorry, for negative power supply, VEE, green for ground, and input blue, and output yellow. All right. So when you create your schematics, you have to pay attention to VCC, VEE, input, and output. Those need to be banana jack connectors. Okay? When you use the software, they have libraries that you can use that's already representing the banana jacks. Okay? So then the first thing you do, you need to create a schematic. This is the PDF. You cannot use this as this. You need to create a schematic in Ego, which has this schematic. Okay? Next, when you create the circuit board cannot exceed 0.7 inch by 4 inch. Okay, so what is a 0.7 inch? 0.7 inch is the width Right, it's the width of your TC 3.5. Okay, for each, it's pretty much the size of your TC 3.5 times 2. So that means you are building a circuit board that is twice the size of your TC 3.5. Okay, you are going to use two layers only, through hole components, no circuits SMTs. Right? When you go through the textbook, you'll know what I'm talking about. Okay? This is the topics covered in the textbook. You must pass the DRC check in Eagle. Now, how do you know what kind of check you can perform? You can download the DRC file from this website. Okay, so this is the website to provide a DRC file for the manufacturing equipment. So this is what we're going to use. So you use their file. All right. Okay. This is public domain stuff. There's no secret. You just download the file, then they'll tell you, hey, these are the limitations. You cannot just do random things. All right. And then I give you the schematic, which is this. But you need to create the schematics in Eagle. Once you have the schematics, you can make a printed circuit board. Okay. All right. And you need to publish the design on GitHub. Now this, I will talk about that later because you don't need to do it now. You have plenty of time to finish it. Okay. So your job right now is to do this section. To do this. Create the schematic, create the printed circuit board design in Eagle, and then pass the DRC check. Okay. Now, Eagle is different from multi-sim. Eagle is not to run simulations. Eagle is for you to do circuit designs. Okay? It has nothing to do with circuit simulation. This class is not about simulating a circuit. If you want to simulate, you can put this whole circuit in multi-sim simulator to see what it does. But that's not the focus for this class. Right? So any question about this? Now this is not due right now. This is due much later. Okay. Um, the due date is April. Sorry, it's 1 week after that. It's May 7th. Before class start. Okay. So we're talking about 4 weeks. All right. Is it 4 weeks or 3 weeks? One, two, three, 3.5 weeks. All right. So the schematic is on Euler. Right. So any question about the schematic, the banana jack, and the task you need to complete highlighted here. We'll talk about the publishing of your work later. You don't need to do that. You need to have the files done first before you can publish them. Okay. All right. Any questions? Yes. So please start going through the textbook for Eagle if you have not done that. Because this is a program you need to use for the assignment. It's not something that you'll learn overnight. Maybe you can, you work 24 hours. Okay? You should do that piece by piece. Okay? Alright, so inputs, outputs, power, we're going to use the banana jack. If you go to Eagle, you find the library, banana jack. And this is schematic. It's not very complicated. It's just our up and bunch of resistant capacitors. Right. Okay, the next topic is the midterm. So the midterm was scheduled today. Of course, we're not going to have that today. So the midterm exam, we're going to make it April 23rd, which is next Thursday. It's from 4 p.m. to 5:30 p.m. The midterm exam is going to be online only. You'll see a ULAN post. Okay? The format for the midterm is going to be upload for each question's single attempt. So that means I'll post the midterm, and there will be upload area dedicated for each question. And then you have the question finished, you upload your solution. You finish it, you upload your solution. You do not have infinite attempt to upload. So when you say I want to finish number one, you upload to number one. Oh, okay, then number one is done. So I want to go to question number two. You upload number two is done. Okay, the order of your upload doesn't really matter, but each question you only have one attempt. Okay? What about the topic? So far we have been talking about Arduino programming. So these were the topics covered in the midterm. D1, 2, 3, 4, Arduino programming. We have been doing a lot of programming BMPs and pixels. So this is what you need to do. These are topics you need to cover. Since this is online only, that means you can use computers, internet, doing exam. If you check your syntax for your program, you can use those tools. I'm okay with that. Okay? Alright, so remember this is April 23rd, which is next Thursday, not Tuesday, next Thursday. Understand? Any questions? Great. If you don't have any questions, I'm going to post this notes on YouLearn later today, and the video will be available later. And please work on the assignments and use the VgaEmulator because it's very helpful. You don't need a lot just to do the debugging. And if you need to set up an individual meeting with me through uh, Skype or Zoom, let me know. I can set up one with you. Okay. If you don't have any questions, you can leave the stream. I'll terminate the live stream in a few minutes. Okay.